All right, final thing. Part of physics' job is to figure out what happened. How did we get to where we are, and what the laws of the universe are that are currently operating under it. So the question is, how did things get here? And the answer to the question is we don't know. Anybody tells you otherwise is assuming physics that are not present. In fact, we know one thing. We know about zero point 0.1 seconds after whatever happened, the laws of physics started working. Before that, the laws of physics fail. De facto fail. The laws of physics we currently understand them do not work once you get to a certain place and going backwards in time. So how do we know that? Well, it's an interesting sort of thing. It's when we look at all the galaxies, we talked about this before, we noted that every galaxy is heading away from us. So one argument would be, here's Earth. Every one of these galaxies are moving out galaxy, galaxy. Let's make it a spiral galaxy, a regular galaxy, spiral galaxy. I should make a bar galaxy. Every single one of these are spinning and heading away from us. Well, that makes no like. Are we really the center of the universe? Now, it's an interesting question because we have no proof that we're not, except for the following: the ones that are closest to us are fleeing us the least fast. The ones that are farthest from us are fleeing us the fastest. So, a better model of what's going on is here we are in the Milky Way galaxy, minding your own business. Our next door neighbor, the Andromeda Galaxy, where there is some debate as whether or not it's actually moving away from us. Gravity may be sufficient that these things are attracted to each other now. Enough they might be heading towards each other, but for the most part, it is heading away from us. It's heading this way. We're heading this way, so we're getting a little farther apart because we're all moving away from some place. Like a balloon. Imagine a big balloon being blown up. You're blowing it up, and these places on the outside of the balloon are getting farther apart, and the ones that are farthest apart are moving most directly away from each other, so therefore the ones moving fastest away from each other. This is what we think is going on, is we think all the galaxies are moving outwards. So therefore, why is no galaxy getting closer to us? Because all galaxies are moving away from a central point. Ah. And in what should have been a completely different thing, a guy was trying to invent a cell phone. Now, like cell phones, those existed. Cavemen had them. No, they didn't. Actually, they were invented by a group at Bell Labs. But Bell Labs had several bad choices before they had a good choice. Bell Labs was trying to initially do it with infrared technology. Now, infrared is how your remote control might work for your TV. If you have a little red box in the end of your remote control, it is how your TV gets changed channels. The problem with infrared is it's heat. In order to have heat travel miles, you have to have a lot of heat. And so the plan was never going to work. But they were trying to do some research. And so one of the things they had to do is to figure out how much heat is available in the universe around them, how much interference would they have. So they basically took a heat telescope, which is basically a device that measures heat, and they basically swung it all over the places around the neighborhood. Okay, they basically made it all over the place. They just swept it around all the different buildings, and that's what they're trying to do. Well, story has it, the two of them took their little heat telescope up there and were bored, and they were a little bit inebriated when they decided to, for whatever reason, point it up in the heavens. Now, there's nothing close enough to create much heat, so therefore the telescope was not going to do much, and it was not really useful for determining whether or not you could use your cell phone because you're not competing with the stars. The stars aren't hot enough to mess up your cell phone. But there was something interesting that happened. They noted that almost all space was the same temperature, which is virtually cold, super cold. So they're sweeping the heavens. But they did note there's a place in space that was warmer. That was still vibrating from some heat, and there's nothing there. You look at stars, nothing there. It's a place which is still radiating heat. Where is that place? Well, if you take your spot on Earth, it's something like this. What's interesting is once you start doing the Doppler effects, and once you assume that the reason why we we know how far apart these are, right? We know how fast they're traveling away from each other. We can get some angles, right? And we start backtracking these things. And we discover something very interesting. About 12.8 billion years ago, well, I can't draw a straight line to save my life. Go back how fast it's going, right? Figure out the gravity, boop. Figure out up, boop, boop. You discover something very interesting. Everything was in one place. Also remember the following. Objects, all of the galaxies look like they're spinning. Why is that? What gave them the energy to spin? We also think that our galaxy was full of dust, debris, broken up stuff. It wasn't one big solid chunk that flew off into space. It was a bunch of dust that slowly turned into stars and planets and all the other things. So what is it? What is it that would have heat in the middle, heat that's still there 12 point whatever billion years, would cause every object to head outwards, starting off as dust or debris, and that's spinning? Yes. You've got it. You ready? Debris spinning, blown apart, all heading out from a central location that's still warm when you're done. Yes, the universe is a great big watermelon. No, just kidding. What the universe is, apparently, 12.7, 12.8 billion years ago, there's some other ways you can get a slightly different number. All the mass was sitting in one place. Physics doesn't work at this time. Then, 0.1 seconds later, a bunch of debris is heading outwards from a central point that is to this day still warmer. Still warmer. Those bits of debris were spinning off into space as basically a paste or a powder. Those clumps slowly got together because of gravity and made galaxies and stars and the planets we live on. Why do we believe in the Big Bang? Simply because when you see a bunch of things heading outwards, when you see debris that's spinning, when you see its debris itself, when you see warmth left over from after the explosion, we naturally think of an explosion. It's just that simple. The Big Bang Theory came about as the most practical of all explanations of what we were seeing. And there's nothing beyond that, no deep or profound meaning other than the same meaning of this. It looks an awful lot like this watermelon being blown to bits. And I love this watermelon being blown to bits, so we should always watch the watermelon being blown to bits. So, Big Bang Theory, everything in the universe, all the galaxies, all 2 trillion of those, which each had 200 billion stars, all of that mass, all that matter, looks like it was in one place at one time where physics was not working. Shortly thereafter, all of it was heading out from that central point, leaving behind an insane amount of heat and debris that was spinning off into space. The Big Bang Theory.